Hi guys, you're welcome to God Academy, and in this lesson I'll be taking you through Bernoulli differential equation. In our previous lesson, I took you through separable differential equation as well as exact differential equation. So we continue with Bernoulli differential equation. What do you mean by Bernoulli differential equation? Let me write the standard form of a differential equation for you to analyze. If you have y prime plus p of x multiplying q is equal to multiplying y is equal to q of x multiplying y to the power n. From linearity class, I showed you that for a differential equation to be linear, for a first order differential equation to be linear, the highest power of y should be what? 1. There are situations where the equation is almost linear, but there is a term which has y to be greater than 1, and it makes the whole equation Bernoulli. Okay, so the expression y to the power n here is what is making this Bernoulli, because aside this expression, this whole thing is a linear differential equation. I've shown you how to solve linear differential equations in our previous lesson, so please visit those videos to understand that better. So here, how do we solve Bernoulli differential equation? We do that by getting rid of y to the power n. So the first step is dividing through by y to the power n. We end up getting y to the power negative n y prime plus p of x. This becomes y1 minus n and is equal to q of x. So this is something like uh, a linear differential equation, but we get rid of the expression here, then get rid of the expression here to make this linear simply by using the substitution b is equal to y to the power n. As simple as that. As simple as that. So now let's take an example here and solve so that you understand this better. Okay, so our example here is y prime plus 4 over xy is equal to x cubed y squared. Y of 2 is equal to negative 1, where x is greater than 0. So whenever you see an expression like 4 over x, you have to state that x is greater than 0. So that's what the question has done. For this problem, as I said, it's like linear differential equation. So we need to solve this very well, right? So to solve this problem, what do? We have to get rid of the y squared. As I said, that's the first step. This is like a linear differential equation. We have to get rid of this y squared. So I'll divide through by y squared. I'll get y to the power negative 2y prime plus 4 over x, y to the power, I have 1 divided by 2, so negative 1 is equal to x cubed. Then we come to our substitution, which is v is equal to what? So now it's v is equal to, we take this side, okay? V is equal to y to the power negative 1. We want to substitute the y to the power negative 1 and the y to the power negative 2 here so that we can get a differential equation which will be linear, and so that we can solve. As simple as that. We are just trying to use substitution. So this falls under the category called substitution methods, okay? Bernoulli forms part of substitution methods. We also have homogeneous, right? So look at that. So now with this expression here, what do? We differentiate. Is that not it? If you have v is equal to y to the power negative 1, you simply get v prime is equal to, when you differentiate this with respect to y, you're going to get negative y, right, to the power negative 2. I don't know if you get it. Negative y to the power negative 2, because this will multiply minus 1. But if you are differentiating with respect to y, you need to introduce y prime. Y prime, that is the y, this is the v over dy, right? So you introduce y. What we are doing is dv over dy and dy over dy, okay? But here is, you just attach the y prime. Always don't forget, we attach y prime to it. Once you have gotten this, we come back to our equation here. Remember that we need to make sure that we have made y to the power negative 2 and y to the power 1 here the subject. So making that the subject, I'll have negative v prime is equal to y to the power negative y prime. As simple as that. Then I come back to my equation. I'll replace this section with negative v prime plus 4 over x. This becomes what? My v, as I have here, is equal to x cubed. Now I've converted my equation from y to v, and now it's a linear differential equation, but I simply have to divide through by negative 1 to make it standard. So So I'll have v prime minus 4 over x v is equal to negative x cubed. Is that not it? At this point, I find my integrating factor mu of t, which is equal to e to the power integral of the coefficient of v. Take note. So negative 4 over x dx. This is simply equal to, please take away your constant outside the integration symbol. So that gives us e to the power negative 4 integral 1 over x. Is that not it? Which gives me e to the power negative 4 ln x, giving us e to the power ln x to the power negative 4. Then everything becomes x to the power negative 4, as simple as that. So my integrating factor is successfully equal to x to the power negative 4. I come back to my equation here, then I multiply everything by the integrating factor. So v prime times x to the power negative 4 minus 4 over x v times x to the power negative 4 is equal to negative x cubed times x to the power negative 4. In our linear equation, I showed you that whenever you get this expression, we will collapse it to give us v times our integrating factor all to the power prime. I've explained that, so visit that video. This should be equal to, when I simplify this, I get negative x to the power negative 1. Is that not it? Then at this point, we need to take away our derivative. Our goal is to find the value of v. So to take away the derivative, I'll have to integrate both sides. So integral here, okay? That gives me v times x to the power negative 4 is equal to negative, this becomes what? Negative integral 1 over x dx, okay? So now we have to just integrate this. So integral of 1 over x is what? Ln x, is that not it? So I'm going to have this to be v times x to the power negative 4 is equal to negative ln x. So this gives v times x to the power negative 4 is equal to ln x to the power negative 1. What's the answer? I simply make v the subject. V is equal to ln x to the power negative 4. Sorry, ln x to the power negative 1. Okay, negative 1 plus c plus c plus c, like this. So here, this whole expression divided by my x, I'm trying to divide through by x to the power 4. So it becomes x to the power 4, okay? So if you divide through by x to the power negative 4, I'll get x to the power 4 multiplying this expression. Remember, in the equation, I gave you an initial boundary condition that y of 2 is equal to negative 1. So the answer said y of 2 equal to negative 1. But I have v's here. I have v. I don't have y. So what do? I go back to my substitution place. I said that v is equal to y to the power negative 1. Is that not it? Wherever I see v, I put y to the power negative 1 to go back to my equation. So this becomes y to the power negative 1 is equal to natural log of x to the power negative 1 plus c, okay, multiplying x to the power 4. At this point, I can put y to be negative 1 here, to the power negative 1. Wherever I see x, I'll put what? 2 there. So lane, it becomes 1 out of 2. Is that not it? Plus c. Simplifying this expression, I should be able to find, and I have x to the power 4 here, so 2 to the power 4 here. Okay. So now this becomes negative 1. This becomes negative 1 is equal to, I have 16. So negative 1 over 16 is equal to lane 0.5 plus c. So I simply subtract this and you put this into your calculator, give you the answer. So what is lane 0.5? So natural log of 0.5 is simply negative 0.693, right? So I have negative 1 out of 16, right? Then minus lane 0.5. And that gives me c to be equal to 0.6306. So therefore, I'll say that I have my answer to be 1 over y to be equal to lane x to the power negative 1 plus 0.6306, right? All this multiplying x to the power 4 as the function. You can just reciprocate this to make y the subject. Y is equal to 1 over the expression ln x to the power negative 1 plus 0.6306 multiplying x to the power 4. And that is how we solve Bernoulli differential equation. Thank you for being with me, and I hope you subscribe. Also, see you in the next lesson as I'll be taking you through the substitution method.